All right, this is going to be 6A elementary charges. So let's do number one. So number one says an object cannot have a charge of what? So we know that one elementary charge has a charge of 0.16 times 10 to the negative 19 coulombs. And so one proton, right, one proton would be positive 1.6 times 10 to the negative 19 coulombs, and one electron would be the opposite of that. All right. So, and then that's what elementary charges are. So that's literally one proton or one electron. Now, well, you can't really have half an electron, right? That's not possible. You can have a part of a proton, but we'll get to that when we get to that. But for right now, let's just say that we can't have anything less than one proton or one electron. So if the number is not divisible by this number right here, by 1.6 times 10 to the negative 19, the charge is not possible, right? Because you can't have 1.5 uh, electrons, or 2.6, or 3.7, or 4.2 electrons, right? It has to be divisible by that. And well, let's see how that is possible. All right, so let's take a look at 3.2 times 10 to the negative 19 coulombs. That's choice A. And so if we divide that by 1.6 times 10 to the negative 19 coulombs, these two exponents cancel out. 3.2 divided by 1.6 is going to give me 2, right? It's going to give me 2 elementary charges. 2 elementary charges. So this could be either 2 protons or 2 electrons, right? Or 2 extra protons or 2 extra electrons. So that's possible. It's a whole number. I have 2 full charges. Now let's look at uh B. So 4.5. And so let's just erase all of this again. So let's look at 4.5. 4.5 times 10 to the negative 19 coulombs. And we divide this again by 1.6 times 10 to the negative 19 coulombs. So you divide this, right? So 4.5 divided by 1.6 is going to give you 2.5. 2.5 elementary charges, which is again, this is not possible. Well, let's check again. Let's just check the others. 8.0 times 10 to the negative 19 divided by 1.6 times 10 to the negative 19. Divide that, you get 5. And that works out. We have 5 full protons or electrons. And let's do 9.6 divided by 1.6. We can get 6, either 6 full protons or 6 full electrons. And so the only thing that's not possible is choice B, right? Because you cannot have part of an electron, just like how you cannot have part of a person, of an actual person. So number two says, what is the net static electric charge on a metal sphere having an excess of plus 3 elementary charges? And so if we know that one elementary charge is 1.6 times 10 to the negative 19 coulombs, well, 3 elementary charges are going to have 3 times this one. So this is 4.8 times 10 to the negative 19 coulombs. So you're doing 1.6 times 3, and you get 4.8. And so the answer choice is B. All right. Now let's take a look at number 3. A small sphere possesses an excess of 5 electrons. So 5 electrons. The charge on the sphere is what? And so we know with the charge on one electron is negative 1.6 times 10 to the negative 19 coulombs. Well, 5 electrons is going to give you a charge of negative 8 times 10 to the negative 19 coulombs, right? You're multiplying this by 5. If we have 5 electrons, we multiply this by 5 and we get this number. So the answer choice is B, right? Number 4, a particle could have a charge of what? So again, right now we want possible particle charges. We don't want impossible, we want possible charges. And so choice A says 0.8 times 10 to the negative 19 coulombs. All right. Now, if we divide this by 1.6 times 10 to the negative 19, we clearly get 0.5. We clearly get 0.5. All right. So, and that's part of an electron or part of a proton. So that's impossible. We're going to do 1.2. 1.2 times 10 to the negative 19 is clearly not divisible. Well, you clearly won't get a whole number here. 3.2 divided by 1.6, you will get a whole number. And let's add this. You will get a whole number here. You're going to get 2. And so that's a possible charge. So the correct choice is C. Correct choice is C. Number 5. If an object has a negative charge of 4 coulombs, the object possesses what? So if we know that 1 coulomb of charge, and this is on your reference table, it's on the first page of your reference table, we know that 1 coulomb of charge has 6.25 times 10 to the 18 elementary charges. Well, a net negative charge, well, if we have 4 coulombs of charge, well, we're going to have 4 times this number. So we're going to multiply this number by 4. 6.25 times 4 is going to give you 25 times 10 to the 18 elementary charges. And this is going to give you, and we move the decimal place over, and this is going to give you this number right here. And well, do we have more electrons or protons? Do we have more electrons than protons, or more protons than electrons? Well, the question says net negative charge. Well, if you have a net negative charge, you have more electrons than protons. All right, and so you're going to get an answer choice of B. And B is the correct answer. So number 6. What is the smallest electric charge that can be put on an object? Well, smallest electric charge. Well, the smallest electric charge is this, right? Because that's either one proton or electron, and only answer choice is going to be B. All right.